Okay, so let's unpack this. We've got a really tight mission for today's deep dive.
Mm-hmm.
We're looking for a technological shortcut. I mean, how do you maximize the life and the sheer physical reach of existing video systems?
The ones that are still good, high-quality systems.
Exactly. The ones that still use that, good old composite video, that single cable analog signal. And you want to do it without the budget and honestly the headache of a total digital overhaul.
And that's where we're focusing. We're going dupe on the Thor Broadcast F-4VD-TXRX. It's a 4-channel video over fiber kit.
Okay.
And it's a specific, targeted solution. It's designed to solve that exact headache of extending those standard video feeds. Offy from older, but incredibly robust, high-end security cameras.
So the goal is a smart extension, not replacement.
That's it.
And the core function here seems pretty compelling. It's a fiber optic media converter, and it pushes 4 channels of video across the system. But the technology hook, that's what surprised me. It uses the same high-end 10-bit digital encoding that the manufacturer puts in their full-blown broadcast transmitters.
Yeah, they've basically put broadcast fidelity into a much simpler and less expensive chassis.
Okay, so let's dig into the specs that really matter.
Well, what's fascinating here is looking at the core performance. When we talk about distance, this kit just changes the rules completely.
How so?
It supports an incredible range. We're talking up to 20 kilometers when you're using single-mode fiber.
20 kilometers.
20. And even if you're stuck on, say, older multi-mode fiber, you're still getting 3,000 feet.
20 kilometers is a massive operational distance. I mean, if you're managing a sprawling university campus, a correctional facility, maybe a remote pipeline, that range changes the entire calculus of your infrastructure planning.
It really does.
But let me push back a bit. If this isn't a less expensive chassis, where are the trade-offs? Where does the quality suffer?
That's the key question, isn't it? But the trade-off isn't really in the signal integrity. They protect that analog signal using that 10-bit quantization. That's sort of the magic number for minimizing digital noise, reducing banding, especially when you're dealing with subtle light changes over these massive distances.
So what's the result?
The result is an impressive signal-to-noise ratio. The spec is greater than 67 dBs.
A 67 dB SNR over a 20-kilometer run is genuinely impressive. So, okay, we've covered the visual fidelity. But if you're running security, you need control.
Of course.
That brings us to the multifunctional side. The D in the model number F-4VD-TXRX, fan size, I'm guessing that tells us it handles data too.
Absolutely critical. By default, it features return unidirectional RS-485 data going in the opposite direction of the video.
So what does that mean in practical terms?
It means you can monitor the video and send commands back down that same fiber link to control, the pan, tilt, and zoom, the PTZ functions on those remote cameras.
One fiber for everything.
A single fiber link for total control and monitoring.
And this is crucial for some folks listening. The solution is noted as TAA compliant. That means it meets those specific trade agreement standards for U.S. government procurement.
Right, and for certain sensitive installations, that's a non-negotiable.
And if you need something other than the standard RS-485 for, say, industrial control, they do have RS-232 or 422 interfaces available as a special order.
Yeah, and just one quick clarification on the multimedia side. While this base model lacks analog audio support, the product line can handle it.
Okay.
If you move to an audio-enabled model, the performance is stellar. We're talking 24-bit quantization and an SNR greater than 75 dBb. It just proves the whole platform is really designed for professional AV transport.
So what does this all mean for you listening? We've seen a device that leverages broadcast-level digital encoding to send old-school composite signals over fiber.
Yeah, essentially future-proofing legacy systems.
You get high-quality, TAA-compliant transmission over extreme distances, and it's complete with control data. I think the lesson here is that sometimes the smartest modernization isn't just replacing hardware.
It's about radically upgrading the transport mechanism.
Exactly.
And this raises, I think, a really important final thought for you to consider. Think about the economic and the logistical value of extending the operational life of your perfectly functional analog equipment, like those high-end cameras, versus the immense cost and disruption of a full digital conversion.
Especially when long distance and control are the main goals.
Right. When high-quality, long-distance performance is what you need, this kind of cost-effective bridge makes a really compelling case.